So welcome to my scenario description S1, which will cover the checkpoint restart feature of the SORRIR ecosystem. What will my scenario be about? On the slide, you can see the general architecture of the use case, and the component which will be especially important will be the PMS component. The PMS component is responsible for storing most of the state of the application. So, for example, the reservations that can be made by a customer will be in the end stored in the PMS component. And what could be a problem here if the PMS component crashes? Then even after the restart of the software component, the state, like the made reservations, can be lost if there isn't some persistent feature activated on this component. So what does this general story look like? We will have a look at a customer who issues a reservation via the web service of our smart parking garage application. And the customer is doing this in an interactive way. And the customer will succeed in doing this reservation. And in the end, the PMS will store the reservation and associated information, like that the reservation is given within a given time frame and for a certain parking space. But after the reservation was made, and while on his way to the garage, the PMS component crashes. So how does this end for the customer and for the smart parking garage? If there isn't some feature of the SORRIR ecosystem used that will be able to keep the system in a consistent state. In this case, it will be the case that the data will be persisted in a volatile way in the PMS. And this means that when the component crashes and even after the restart, state information like made reservations will be lost. And this means that the whole smart parking garage system will be kept in an inconsistent state. So what can we do to avoid this? We can use the SORRIR feature called checkpointing. And in practice, we can configure the application beforehand that the component PMS has the checkpoint recovery feature enabled. And with this checkpoint recovery feature, it is possible to retrieve the state. And this will also be done in a very lightweight fashion. So there does not have to be a sophisticated database management system in the background. This will be done with a very lightweight way by just persisting this information in a JSON formatted file, non-volatilely, so that it is possible to retrieve the state information. So now I want to show you how this will look like in practice, and we will take over to the demonstrator. Before we do that, we will have a look at the case where this feature is not enabled and where the system will get into an inconsistent state because the reservations will not get persisted. So as you can see here, we have our architecture in front of us, and to simulate this scenario now, I will do an offsite reservation, which in practice will be done by the customer. For this, I will paste into this parameter field the information that is associated with this reservation. And what I also need to do is to choose the correct component to send this event to. And as was said in the slides, this will be the web service. So I'm choosing here the port, which will be the user service or which will simulate the user. And I already inserted the payload up there. And now I will send the reservation request. Now the event has entered the system. The PMS component should now display that the reservation has arrived. And as you can see in this field here, this is the information that is associated with the reservation. And to simulate the case now where the system gets into an inconsistent state, that is crashing the PMS component. This I will show you now by clicking this fail selected unit, which will cause the PMS to crash and to restart. And after the restart, the reservation should be gone because there's no persistent storage available in form of a checkpoint. So this is what I will do now. So you can see here now the PMS was for a short period of time in the state unreachable, and this caused the reservation to disappear. So this was the case where the checkpointing feature was not applied. And next I will show you the case where we will use the checkpointing feature and everything should work in this case. So now I will show you the checkpointing feature in action. The situation is the same as before. The customer makes his offsite reservation. He talks first to the web service, and we can simulate this again by clicking on the web service and then selecting the from US port. As before, we use the same payload and we are choosing the request reservation type. We check the request flag and now we send the event. And as we can see on the state of the PMS, the reservation has entered the system. But now comes the interesting part. If I now fail the PMS unit, the reservation should be persisted and should not get lost. What I will do now is again fail the PMS unit. Now it will toggle to unreachable and will restart again. But compared to the case without checkpointing, the reservations are kept in the system and the smart parking garage can operate as expected. The state kept consistent and every stakeholder will be happy.